Hello and welcome to another tutorial. So this time around we're going to be taking a look at the area of how we can create markers for a heads-up display for a HUD. And in particular with this we've got a couple of interesting challenges there in that when we've got the markers are on the screen in front of us, so the object is fully in front of us and it's within our field of view, that's actually quite straightforward for positioning them. However, when the markers are behind us, that's when it gets a little bit more interesting in trying to make that work. So that's what we're going to be taking a look at of how we can actually get that set up. And again, similar to all of the projects, this is going to be something that we build in a fairly modular way so that you can add this into your own projects. So starting point, I've already got set up here. This is based upon the Look to Interact tutorial. So we're going to use this as our starting point for actually building up our system for our HUD markers. So a couple of things we need to get up and running with this. So firstly, I want to be able to nicely group everything. So we're going to have this in their own separate folder. And what we'll be doing here is we'll have a few scripts. So if we think about it, we've got a couple of different aspects to this. So we have an object that's positioned somewhere in the world. So we have an object anchored somewhere in our world. And then we're going to have something on the UI that links to that. So we've got a couple of aspects to this. So there's a few scripts that I'm going to set up is we're going to have our HUD marker, and so this is going to be the one that's sitting in the actual UI. So HUD marker UI, or HUD marker target, I think is a better term for it. So the target UI. Then we're going to have a separate script that is our HUD marker manager. So that'll control the UI, just organize all of the positioning there as needed. And then finally, we're going to have a script, so HUD marker in world target. So this is going to be the thing that we place in the world. So what I will do to start off with is I'm going to take this one and move it way over here. And each of these will get that HUD marker in world target. So these are going to need a couple of things. Now these already have a description on them. So for the interactable, we already have a description there, but I'm going to set up just so we can have a name. And we might make it that this can control the image, for example, that gets shown, so that could be a handy thing. So serialize field, this is going to link to a texture 2D, and actually it's going into the UI, so we'll actually use a sprite for this, I think will be better. So HUD sprite. That looks good. So that means we can get those set up on the particular objects. And what I might do is just have a folder here for the sprites. And we'll just set up, we'll create a couple of very simple sprites for our system. So we would need to actually add in our sprite setup. So we'll end up grabbing a couple of textures that we'll throw in there that we'll be able to use for our HUD marker sprites. So if we take a look at these, well, these both get the in-world target sprite-wise, and we actually do have a couple of UI ones we can use. So what I'll do is I'll actually set these both to using the knob sprite, should work nicely. So for the one-shot interactable, this one, what did I name this? So those were just, particular timed and everything. So we'll just set these one shot and timed. So those will talk to our HUD marker manager and say, hey, I'm something that has a HUD marker target. Please add me into the world. So then we need to set up our HUD UI. So this, I'm going to intentionally set this up as a separate canvas. And there's a very specific reason why I'm doing that. I'm doing that because I want this to be easy for us to change and shift this around if we needed to at a later point. So we'll set up our canvas. So this is our HUD canvas. And as I would generally do, set it to scale with screen size. I think 20 by 1080 tends to be good. And we'll set up a panel. So HUD markers. Again, just useful to have the stuff grouped. Now we don't want an image on this. And our HUD canvas, we also want to remove the raycaster, because this we're not having it interact with anything, so we'll remove the raycaster. So we've got our HUD markers there, which is good. And the actual HUD marker manager, we'll put that onto our HUD canvas. So HUD marker manager gets that. And so it's going to need a couple of things. So we're going to need a general prefab for those HUD markers. So let's set up a folder for our prefabs. And then let's create a basic prefab for this. So again, I'm going to set up a little panel, and this I'm going to call HUD marker. And the reason I'm setting up a little panel for this is because I just want to be able to easily control the appearance of it. If we go over to the game view so we can see a little bit clearer, and the size of this is obviously going to need to come way down. So 300, let's drop that more to something like probably 100, I think is going to work out about right. I'm going to give it a little bit larger in height, potentially, because then what I want to do is there's a couple of components to this. So it's going to need an image, which will be our sprites. I'm just going to pick a default one. And I'll make it one that I'm not currently using. So I'm using the knob one, so I'm going to use the input field background. I want to anchor this to the top. And we'll set it so that its Y position is just a little bit down from the top. We'll indent on the sides. And so that should mean at a width of 100, if we drop this height to 90, then that'll be square, which is what we want. Because this is just so we can have a little bit of text below that, because I want to have enough space that we can have just a small line of text for indicating the details of this marker. So we'll set up our text mesh pro. So name, and this one's going to need to be anchored down at the bottom, just above. So that looks good. And we'll center this. So this will again give it a little bit of a buffer there. Now the size of this text here needs to drop quite a bit. Maybe get away with 20. That looks about right. A little bit more of an offset. And so this, if we check and see with our particular ones, we've got timed and one shot, so we can test and see. One shot, and that fits, just. We might also want the distance in, so that could be a cool thing of 1,000 meters. So with that, what I would do there is we can increase the size of that panel a little bit. 100 by 150, that seems about right. For the text here, we might want to enable auto sizing. So I think the max we'd go to is 20, and the min, I think we aren't going to be able to reduce the size too much before it becomes unreadable. So I'd maybe only allow it to drop it to as low as 14. And we can test because we can see what size it's reducing into. So yep, that seems about right. I think if we let the font size drop any more than that, that would be getting too difficult to actually sort of see. And then what I would also do is for the image, I'm going to change this so it's actually now being anchored at the bottom. Because I think that when that text and everything expands, it keeps that text nice and closely attached to this. And turn off our image, so we're not actually showing anything behind that. We could have a little bit of a panel there to darken the background if we need. So that actually might leave it on, but make it that this is dark so that it is hiding that background a little bit. So it lifts the text out a bit so we can see that nice and clearly. So that looks all right. We could reduce the size a little bit if we need. We know the ratios we need to keep here, which is good, but I think that size is quite good. I'm just going to turn off, not that it strictly should be necessary, but I want to turn off raycast target on all of these because I don't want them interfering with anything I'm able to interact with in the world. So this gets our HUD marker script, so it gets the target UI one. And this is going to need a link to that image and to the text. So these ones can be a serialized field, and we're going to need Unity Engine.ui, and we're going to need TM Pro. So this gives us our Text Mesh Pro UGUI. So our linked text, serialized field for the image, linked image, and then we also are going to need to be storing our target. So HUD marker, in-world target, linked target. So this will end up, and we don't want to serialize that because that's information that we set up dynamically at runtime. We will also give this a bind function. So the idea behind this is it allows us to set our target and everything associated with that. So our linked target, or our target, we'll let it provide the text and also provide the image. So that will be provided as a sprite. And then what we would be doing is we'll just set these particular ones, link target, linked text, dot text, like that, and linked image, sprite, is equal to that. Just so we can link these up, because then we'll turn this into a prefab. So that'll be the key things. We get these set up. So we link our image up and we link our text up. That looks good. That means this is ready now to be prefabbed. So we'll make that a prefab, which means we can remove this. And then we can start to set up our HUD marker manager. So it's going to need serialize field, game object, marker prefab, because it needs to know what it's instantiating. Also needs a transform, the marker root, so the core root location where it gets spawned at. Because then we will have add marker. Now we need to be providing HUD marker in world target. We need to be providing the text for it, so our text, and we need to be providing our image. What this will then do is we instantiate our marker prefab and we place that. Our initial one, we're just going to put that at 0 with a no rotation, and we place that at marker root. So this is going to be our new marker. So instantiation is straightforward. Then we would say new marker, get component, and this is our HUD marker target UI. Bind to our target, set the text, set the image. So that's pretty good, because this allows us to, our in-world targets can very easily access this. So what I would often do is I would make this a singleton. So we'll set up a public static HUD marker manager instance that anything can get it, but it is a private set. Strictly don't need to initialize it to null, but force of habit from a lot of time working in C++, and it's kind of a habit I intentionally keep in just to avoid going into C++, forgetting to do it, and running into all manner of bugs. So instance is equal to this, and for good measure, as a bit of safety, if instance is not equal to null, we destroy game object that's trying to create another one, and we'll just output an error. So not strictly necessary, but good plan just as a safety catch. Found a duplicate HUD marker manager on GameObject.name. This means if we do have a duplicate, we pick it up and we can flag that issue there. So that means our in-world target, well, on start, it can go and say, hey, HUD marker manager instance, and then add marker. And well, the target is ourselves. We've got name, and we've got HUD sprite. Now we might want to have our target know when it's actually getting, when this object is getting cleaned up. That's something we'll be able to do. We could have it directly tell it. We also can just have the marker pick that up itself. Key thing we want to be checking though is that this is actually working. We should see stuff is not going to be positioned where it needs to be. So that is definitely not going to be positioned where it needs to be yet. But what we're hoping for is to see that it does actually spawn those markers, that we can see them. That's the starting point, that we've got markers present. So you can see it's created two markers, and we can see they've got both got their image, they've got the text, and the text and image is set correctly. So now we can start with the hard part, which is the positioning of these. So this is where this will be getting set up in update. Now the positioning of stuff, this is not the simplest of process for how we have to go about doing this. But what we're going to do is essentially have two approaches. One for when it is positioned in our field of view, and one for when it is positioned outside of our field of view. So we first need to work out, is this in our field of view? And we can do that. So what we do first is we need to go, hey, camera.main, and on the camera, we've got some really handy things. In particular, world to viewport point, because I can give this our linked targets transform dot position, and that will give me back a location in terms of in the viewport. So viewport pos. Now the other thing that I'm going to do here is I'm going to check if linked target is equal to null. So if it's been cleaned up, then what I want to do is, well, firstly return, because we don't want to continue running, but I will also destroy game object. So if our target has been removed, then remove the marker. So, okay, we've got that handling for if it gets cleaned up. We've got this viewport position. Now the viewport position, the way the coordinates work with this is if the X and the Y value are on screen, then the x and the y value must be between 0 and 1. And the z value must be positive. Anything other than that specific combination is off-screen. So, is the target on screen? Now, this does ignore things that are including it, so if it's behind a wall, it will still pick it up, which is fine. So the way we tell if it's on the screen is if viewport position x is greater than or equal to 0, and our viewport position x is less than or equal to 1, and same again for y, greater than or equal to 0, and viewport position y is less than or equal to 1, and viewport position z is greater than 0. Then it's on screen. So this case, we can update the marker position for it being on screen. So in this case, what we would be saying is reposition marker on screen, which let's go for on screen reposition marker. On screen reposition marker. And then now, how that logic works is able to be a lot simpler. So our on-screen reposition marker. So we know it's bounded within the screen, which makes it a lot easier for positioning it. That makes it significantly easier for being able to position it, because we can actually say directly to the camera, we can go, hey camera, world to screen point. So our location on the actual screen is something that we can be getting. So with that, we give it, again, our linked target, transform position. So vector 3 screen position. And what we're going to do is we're going to just log this out. See what the ranges are that we get with this. So screen position. So this is just our starting point. Is logging this out because we've only got one on the screen at the moment, so we should only see output coming for it. So it's not going to be positioning, so we can see we're getting 900, 488. We can ignore the Z value. As I pan across, we can see the X value, and so down the very bottom there is going to be about 0, 0, and then the top right value is going to be much larger because that's based upon our actual screen dimensions at the moment, so the dimensions of that viewport. So that's good. We can be getting then our location, and what I would generally do is, okay, well, screen position dot x, because we need to be able to convert this to coordinates that work for a UI. So to be able to do that, we have to take that x and we divide it by our screen's width. That's going to give us a value that is 0 to 1. So that's good. But if we look at when we were positioning the markers, let's drag a marker in here. So that position in the center is 0, 0, which is not where, we could change how that's anchored, but I think anchoring in the center makes most sense. What that means is we've got a 0 to 1 value, but actually we don't want a 0 to 1 value, because again, if I bring that marker back, we need that to go from minus half the width to positive half the width. So we have a different range. So this, I want to do that division. I want to subtract 0.5. So that gives us a normalized x position, which then I can actually modify that, or multiply that by the width. So what I would also generally do here is I would set up something like retrieving the rect transform. So if we get our rect transform, and this is for our canvas rect. Well, this is for our HUD marker rect, which that, pretty easy to retrieve. That is going to be rect transform of the parent that we are sitting in. So rect transform of our transform dot parent. So that gives us our HUD marker rect. So we take this and then we can multiply that by HUD marker rect dot rect dot width. So this is our x coordinate. So float marker x. And the same process we used here, we'll use for the marker y value. So our marker's y value is going to be screen position y, we use screen height, and again we use height here. So that will rescale things into the right location, because then what we're able to do is we can take our transform, we convert it to a rect transform. So this, and what we're setting is the anchored position. So anchored position is a new vector 2, marker x, marker y. So we can test this and make sure that it's positioning it correctly. Because what we're expecting to see is as long as it's on screen, it's located roughly where it is in the world. So let's run this, and we can see that looks correct, and it's following as we move around, which is good. As soon as we get to the edge, it breaks, which is as expected. So that is looking good. We can add in some distance to this, I think would be a useful thing as well. So we could be updating the actual text. So what I could do is I would cache the marker text. Do that, which that would allow us to, every time we do an update here, we can say, okay, link text dot text is equal to our marker text plus, we add in a new line, and then we add in, we can do a vector 3 dot distance of our link target transform position to the camera dot main dot transform dot position. So this, I might pull this out into a separate variable. Let's make this an integer. So var distance is a mathf, and we'll do a floor to int, I think will work best. So then we add in some little text here. This will be in the distance. Then we're showing how far we've got to go to get to this point, which I think that will look quite cool. So let's test and make sure that's working as well, because that means we're getting a little bit of feedback. That's always a useful thing to be providing there for players so they know how far they've got to go. So that looks good. That's changing. Quite happy with that. All right. So now comes the fun part, handling when it is off screen. So handling when it is off screen is absolutely more complicated. So we're going to have off-screen reposition marker, and we'll set this up. Now, as I said, positioning it off-screen is a lot more work. And the reason for that is it's actually really quite complicated to do. We can't just rely, and it can look like you can very easily just rely on things like the conversion to screen space, so that world to screen point, because it looks like it's giving roughly the right values. It looks like it's giving us things that make sense, and it's close. And in some cases, it will actually be about right. But it won't always be. It's not consistent. And so getting something that works consistently with it, and in particular, we want to try and have that transition between on and off screen be as smooth as possible. So what we actually do is we're going to work out where it's located based upon its angle, and we can build off of that. So there's a few steps we need to jump through, and again, I will preface this with, this is going to be very math heavy. It's unavoidably math heavy. There's no two ways about it. It needs a lot of vector maths and a lot of trigonometry, but this will be something that we'll walk through it progressively and get bits set up for it. So first thing we need is we need to get the distance, the vector to the target. So vector 3, vector to marker, to the target. And so that's going to be our link target transform position minus, and again, this is based off of the camera's position. So camera.main.transform.position. Obviously, if you're working with multiple cameras, things like that, there's extra stuff you would need to be doing there. So we need to know our field of view. And we need to know both our horizontal and vertical field of view. And if someone changes screen resolution, these can change. So we need to actually cache this information. So what I'm going to do up here is cached FOV horizontal, and we're going to default that to a value that is knowably not right. Have our field of view vertical again, and also we need to cache the aspect ratio. So aspect ratio. The first thing we want to do is refresh those bits of information if we need to. So refresh cached data F changed. So our camera, we can directly ask it the aspect ratio. So if that aspect ratio is not equal to the cached aspect ratio, or we want to check if the field of view has changed. So we can also go and say, hey, camera.main.field of view, that is different. So the one we cache is our vertical field of view. So when camera is saying field of view, that's the vertical field of view. So with that, we recache the data. So for the field of view vertical, that's easy. It's our camera main field of view. For our aspect ratio, it is also quite simple to grab that. Now, for the field of view horizontal, we have to actually do a calculation. So this, we say, hey camera, convert from a vertical to a horizontal field of view. Then we give it our vertical field of view, and we give it our aspect ratio. So we have to do that calculation there for getting the horizontal field of view. Once we've got that though, then now we can start to do some calculations. So the first thing we want to do is we want to work out where we are X and Y. And we're going to do this using a mixture of some trigonometry functions. So we're calculating specifically the angle to something. So this is how we're going to go about doing this. So normalized X, it is going to be, so first thing we're going to do is we're going to do a little bit of dot product. So we'll break this down. So we do a dot product of our vector to the target with camera.main.transform.right. So it's projecting the vector to the target along the vector, essentially the horizontal vector for the camera's plane based upon where it's facing. So we've got that. We'll do a similar thing for normalized y, vector 3 dot, and then we take our vector, the target, camera, main, transform, and in this case, the up. So, okay, we've got our projection along those axes, which is good. That's a starting point. Once we've got that, we are then going to turn that into an angle. So, go and we convert this. So, our dot product evaluates to the cosine of the angle between things. So we're going to convert this with a cos, and this is something that we'll likely need to tweak afterwards, but we'll convert it to a cos for now. So that angle, we then need to, that's going to be in radians. So our field of view, though, is in degrees. So what I would do to normalize this, and I'll hide this, we've got a bit more room, I multiply this by our mathf rad to deg to convert it to degrees. Then I divide it by my horizontal field of view, which I halve, because the horizontal field of view covers the whole angle. We want to halve that. So a similar thing then happens here, where we take our, convert it to degrees, and we take our field of view vertical, and again, we have to halve that. Because the field of view is referring to the value we get back, it'll be something like, say, for example, 120 degrees. In other words, 60 degrees either side, left or right of where we're looking. So we do need to do that conversion there with this. So what this is doing is we're getting the angle, and then we're taking that angle and we are normalizing it. So we're converting it into a 0 to 1 range. So what I want to do is just actually log this out so we can just get a sense of what the values look like that we're getting. That plus normalized y. And what I will do is I will turn off one of the markers just so we've only got one that we're working with. So I'll leave the one-shot one on and turn off the timed one. And then let's run this. And we just want to see what we're getting output-wise in the console. So at the moment, we're getting nans. So that potentially means that we've got, that'll usually happen from something like a cosine of that happening with an invalid value. What is quite likely is this might be happening too early in the process, so it might be something where it's trying to update far too soon. We can see where the nans are coming from. So they're actually coming at this point where it's trying to output the values. So the actual value it's calculated is a nan there. So if we turn this off, and we'll just run this again, and we'll see where that's actually positioning. So at this stage it's fine. Then as soon as we go off screen, so we can see the X value is proving to be a nan. And we see the same when it goes off screen for the Y value. And so that means that the inputs that we're calculating here, it's managing to get not a number. So what we can check is that it's actually coming through and doing stuff like the dot product there, the kinds of values that it's getting for it. So if we take a look at this, Well, one of the things we definitely will have run into is this vector to the target. We need to make sure we normalize that. Otherwise, we would have to be dividing by the magnitude here. So let's test with that change. Because cosine of a value has a very specific range, so as soon as we do an acos of an invalid value, so now that's looking better. So we want to test, okay, we've got it be below the screen. So as we pan across, you can see the value is changing, and that's looking pretty good. It's not quite changing how we would expect, though. So we see the range that it's moving between. It's moving between a fairly large range. So what we'll generally find is we actually need this to be a sine. Now we'll run it with this setup, and then, okay, we're going to go off screen now, and so we can see our x value is near 0. Our x value is changing over to -1. Go this way. It's also changing over to +1, which is good. If we go off screen with it about in the middle vertically, again, those values are changing about right. So although acos would be the intuitive one we would go for, we actually need a sine for this. But we've got something now that is changing between our key ranges, which is great. So that gives us our normalized angles. So calculate normalized angles to target. Now what we can do is we can clamp this into the range that we're after, because that's giving us a -1 to 1 range. We want to reduce this range down to something that's a little bit more useful. So what we generally do is, okay, our normalized x, well, we want to clamp you because we want to get this into a 0 to 1 range. But our input is going from -1 to 1 and actually a bit outside of that range. So what we would do is 0.5 times by normalized x plus 1. What that will mean is that when it's fully off on the left-hand side of the screen, it will be, rather than being -1, it'll be 0. Whereas when it's fully off on the right-hand side of the screen, it will be 1 rather than the other values that it was hitting. So this just constrains it into a better range for us. So normalized y, we do the same process. So again, a clamp, 0.5 times by normalized y plus 1. Whoops, yeah, plus 1. Always easy to get confused. And then we'll log those out just so we can see those values. And this time around, we'll test a little bit more of a turn happening. So we're expecting to see this be values between 0 and 1. And we want it to be 0 when we'd expect that marker to be over towards the bottom left of the screen and 1 otherwise. So we're getting 0 values there, which is good. And the x value ramps up over to 1, and it means we loop around, and once we pass the point where we're turning directly opposite, so it's picking that shortest angle, which again is what we're after. So now we've got a really good 0 to 1 range. That's working the way that we need. So clamp to a 0 to 1 range. So now we're most of the way there. We've got a lot of the key bits. We've got that 0 to 1 range. But one of the things that we would find if we just position based upon this is there will be a couple of bits where it glitches. We're going to leave it for now so that we can see those glitches and see how that happens. And we're just going to position this particular one. Now the positioning is reasonably straightforward. Screen position. We are going to be able to say, so similar to how we set the anchored position here, it's going to be set to a new vector 2. So again, our marker x and y, if we take a look at how we would get those, well, we're going to be using normalized x and normalized y for both of them. So we'll have normalized x and normalized y, and we need to do a conversion largely the same as what we did before. So this is already a 0 to 1 range. So this part here is reducing that to a 0 to 1 range. So we're actually, this part of it here is what we're after. So I'm going to just paste those in as an easy way to get that set up. By, and then the height. So let's test that and see how that's behaving. What we're looking for is when we go off screen, it's largely in the expected position. And we can see it is. So it looks pretty good. We do see how it floats like that. That's that problem I mentioned that we're going to be focusing on fixing in a moment. And also that is not a behavior that we really want because that gets confusing. So time to fix that side of it. So position the marker. So what we want to do is, because when we're off screen, we want that marker always at the edge of the screen. So we want to take wherever the marker is currently located and we want to push that out to the edge of the screen. So what we have to do is we have to actually work out which edge of the screen we're closest to. So that's what we're going to do next. So we're going to find the closest edge of the screen. So it's a little bit involved, the code here. It almost doubles the amount of code that we've got here. So first thing we do is distance to, and this is the distance to our various bounds. So we're working out the distance to the top right and the distance to the bottom left. So distance to top right is a new vector 2. So top right is going to be 1, 1. So it would be 1 minus normalized x. We'll make sure we're making it clear it's floats, and 1 minus normalized y. So that's the distance to the top right. Then we get our distance to bottom left. And this one's a lot easier because this one is just normalized x and normalized y. It's very straightforward because we've got that 0 to 1 range. So that's good. Now we can get our smallest x value. So smallest x, and that we use mathf min. So we take the minimum, and what we're taking the minimum of is distance to bottom left dot x, distance to top right dot x. So that tells us which one we are closest to. Then we do smallest y, similar process, mathf min, distance to bottom left dot y, distance to top right dot y. So now we know what our smallest x and our smallest y values are. And then we get our smallest distance. Smallest distance is equal to one final mathf min, smallest x, and smallest y. So the idea behind this is we're working out which edge of the screen we're closest to, and then we're going to pull the location over to that. So now we're going to say we're clamping to edge of screen. So how we go about this is we check and see, okay, well, that smallest distance, is that smallest distance the distance to the top right's x value? In other words, are we closest to the right-hand side of the screen? If we are, then our normalized x becomes 1. So we push the normalized x value out to that side of the screen. And then you'll see we do a similar process here with, okay, well, if the smallest distance is actually the distance to the bottom left, well, in that case, then the normalized x is 0. So we push it out in that way, and the process for working with the y value is the same. In each case, we're wanting to find the one that we are closest to, and we modify that corresponding normalized value. This will push that position out to the edge of the screen. And what we'll now find if we test this, run it. So behavior there is as before, but we don't get that little bit of floating that it would do. It's always staying around the edge of the screen, which is great. And then as we move around here, remember before it was floating out into the middle. What will happen is we'll hit a point where it's then saying it's behind us, which is good. And then it flips over to the other side. So we've got a HUD marker system. So the key components for this HUD marker system, and it's not dependent on any of the other setups that we've got there, we have our marker target that does all of the heavy lifting. It has to handle the positioning, and it has to handle that with a couple of little tricks for handling if we're on screen versus off screen. On screen, really, really easy. Off screen, a little bit more work because we need to get a location, then we need to push the marker location out to the edge of the screen. So it is a bit more work, but we're able to then get it appearing really nicely, which is great. So that's the one that does the heavy lifting. The marker manager doesn't really have to do much. It just actually instantiates and passes on the data. So it's quite straightforward. And same for the world target. So there's very, very little in those sets of code. It's all in our main actual target. And then we can go and test this because we want to make sure that we can actually, because one of the things we did was when we pick stuff up, we can see that HUD marker gets deleted, which is exactly what we wanted. We wanted things to be getting cleaned up when we weren't needing them. And we should notice also our distance does update when we are off screen. Now, that's something where what I would generally do is I would actually turn off that distance display when we're off screen. And because we've got two very different code paths, we could actually control what images, things like if that gets shown, depending upon whether we're on or off screen. So we could actually really customize this to have a specific marker that is used when we're on off screen versus on. We could also have stuff where those markers get removed when we're within a certain range. So there's a lot of different things we could be doing there with that. We could change the level of detail of information we see based upon how far the marker is away from us. The one thing I will do is linked text dot game object set active. So we'll have it on when it's on screen, and we will just turn that off when we're off screen, just because that will look nicer. We could also, we're controlling where those markers get moved to on the HUD, so we could actually control the particular location. So we're still seeing our markers there, and that's because that needs to be false. So yes, we could make it that those ones, when they're off screen, that they don't push fully to the edge of the screen. We could have a little bit of a boundary buffer there if we want. We can see no distance, get closer, and then we see the distance. So really straightforward setup there and gives us a really good effect. Thanks, folks. I hope you found that helpful. If you're looking for the code for the project, then as always, that code is up on GitHub, and I've put the link to that in the description below. You can freely use the code for this project in any of your own projects, whether those are commercial or non-commercial ones. And with this, if you've found the video helpful, please do chuck in a like and subscribe. It really does help out. If you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and the link for that is in the description below as well. Bye.